next talk is Spectre for Mere Mortals by Rustemeyer. Enjoy.
Thank you. Spectre for Mere Mortals. This talk will not be about explaining Spectre. It will be about the difficulties of explaining Spectre. And this is something we came up. The talk was originally submitted by a colleague of mine who unfortunately cannot attend this event himself. But it came from a frequent problem we encountered in our business as security consultants with this type of vulnerability, which is highly complex and which is actually difficult to explain to the people who have to make a risk decision on how to handle this and how to react on this properly. And we talked a bit about this problem that we encountered and of possible approaches, and that's what I want to cover in this speech. A slide about me. I'm working at a German security consultant, High Solutions, and we do all types of services in the IT security sector. What is the actual problem behind all this? The problem is that the systems that we use, the information technology that we use, is rapidly growing in complexity. I found this fact that if you look at the code that powered the space shuttle, it is much, much smaller than something that we encounter in everyday life on the internet nowadays. So we have vast code bases for operating systems. Things like a web browser are millions of lines of code with absolutely high complexity. And this has different effects on the security problem. One is that with the size of the code, the number of vulnerabilities and errors in the code also increases. This is quite trivial. We have a typical ratio of vulnerabilities per lines of code. Then with an increased number of lines of code, we will also have an increased number of vulnerabilities. But that's not the only effect. With this increased complexity, we have also more vulnerabilities interacting with different components of the software, or even different vulnerabilities interacting with each other, making things more serious in their consequences. This trend that I described does not only mean that we have more vulnerabilities that we should expect within our software, and especially unknown vulnerabilities, but we have also to expect that once we find out about them, they may be much more complicated, or may become much more complicated over time. This was something that was especially visible in the beginning of this year, when these processor-based vulnerabilities, known as Meltdown and Spectre, were discovered and published. This was a series of vulnerabilities published in January. Originally, there have been a number of variants published after this, and still this is, I think, an ongoing process. Once this class of vulnerabilities has been discovered, people actively look for other types of this sort, and we have ongoing publications of different types of this class of vulnerabilities. So this will still be valid for some time in the future, that new things will be discovered in this area. Interestingly, this was a new class of vulnerabilities that had hitherto not been in the focus of security people. These vulnerabilities are based on the things how CPUs work, how microprocessors work internally, something that many people that look at software consider as something of a black box that will hopefully do what it is supposed to do. But This was a very low-level problem in microprocessors, and still it had massive effects on business software. So through all those layers of complexity, something that was discovered in the internals of microprocessors could be exploited on a business application level, and that was quite the thing that made these publications special. Yes, this was also a big problem for all sorts of people involved with security, to firstly understand what was the problem, evaluate the possible consequences, and then communicate these to the people that were responsible. Because we as security people, we do technical analysis and come up with some technical evaluation, or maybe even with an evaluation on the business, but the actual decision, what is the risk appetite of the organization, which risk are we going to accept or to run, and which countermeasures should we take, is something that has been decided by management people, and these people in most cases, I'd say, don't have the technical background level to actually follow these analyses that are done by the security guys. So I've collected some things to visualize this. This was a tweet by Joe Fitz, which was published quite early after the publication of Meltdown, and he is a computer security person, and brought it to this nice point. I have 2 degrees in computer hardware. I worked at Intel on the product security team. I was already familiar with Spectre and Meltdown background research, but I still had to reread the new disclosures multiple times to fully understand it. Don't feel bad if it doesn't make sense yet. So even someone who is involved in all this microprocessor architecture things and the developments that led to the publication of these papers had their trouble to actually follow and understand the full impacts of this vulnerability. Many people have tried to write down the problem and explain it, and I've taken some screenshots from different papers. Some are from the actual publication. You can see the yellow machine code, which is from the original Meltdown publication, which is a nice example of the problem, but not many people that are not actually developers can read machine code. In the Spectre paper, we had this image on the lower right, which actually tries to visualize the problem with branch prediction. Again, this doesn't explain itself. And then we had other people coming up with other graphics and schematics showing how things impact each other. And if you look at them, the main point I want to make with this slide is none of these explains itself. So it may help to visualize things if you have someone who is deeply understanding things and pointing things out to you, but it is not a means to transport the gist of the problem just in a single picture. So drawing pictures may help, but it isn't the solution to transporting the problem to the management level. This is another example. It's actually taken from a colleague who covered the problem in a project in exactly this situation. He was hired by a data center operator with the task to explain what do these vulnerabilities mean for our data center operation. And I think he did a nice job on it, but he started by explaining the problem in these words. And if you read this, maybe we go through it shortly. It is actually technical abstraction of the problem. He says this class of vulnerabilities exploits features of modern CPUs called out-of-order execution and speculative execution. Instructions are pipelined within the CPU. And this is actually where I want to point out. This may help someone with a technical background understand the problem. If someone at management level reads a sentence like instructions are pipelined within the CPU, I think we have already lost him. And that's what also happens with the rest of the text. It's all, I think, quite accurate what he writes here, and it makes sense to the technical people, but it's not the language we need to transport these to actually the management level. Okay, I won't go into details of this, but you see there are lots of technical terms in there. If we would transport this to someone who is not a technician, we had to explain every single sentence in multiple ways, and this would take quite some time. And the question is, would that be the right approach? So, David and I discussed this a bit, and we thought there must be another way of bringing the importance of vulnerabilities like this to the appropriate people. And one idea was, why not drop all the technical detail and focus on the main points by forming analogies, images. The idea is it's easier to convey complex information by using images, metaphors, and examples. So we don't scare the non-technical people by using lots of technical terms and things how microprocessors work, but we try to find images that they understand, but they help get an idea of what the actual problem is and what the consequences for their business are. And we set this challenge up for ourselves and challenged us with this task. Can we explain Meltdown and Spectre without talking about microprocessors at all? By forming analogies, and these analogies must give us the opportunity to transport the vital principles of these vulnerabilities without talking about computers. And what we came up with was quite a nice example of a bar. So can we put the problem of processor vulnerabilities in an image that is like a bar joke, like an instruction enters a bar, or it rather doesn't. The shortest form of course, this is not the way to explain the problem, but it's the introduction to our bar example. So we had the idea: can we think of a situation in a bar that is similar to this problem? And we tried, and I think we came up with something with the bar metaphor. Our computer is a bar with a barkeeper processing different customers' orders. The barkeeper is our microprocessor in this image. And we have some customers who want to keep their drinking habits private. They don't want us to know what they order and what they drink, in what quantities and what types of drinks. We are the malicious customer who wants to gain illicit information. We want to find out what one of the other customers is drinking. So the scenario is for Meltdown, first vulnerability. Our task is to find out what is Bob's favorite drink. Bob won't tell us, but we can follow him into the bar. And we watch him go to the counter, and he orders something, but we cannot hear what's being said. He whispers to the barkeeper to keep this a secret. And the barkeeper starts preparing the drink, and in that moment, Bob spots us standing behind him. And since he wants to keep his drinking habits private, he quickly leaves the bar. He stops the process. He says, "This is no longer secret. I'm being watched, so I leave." Now we go to the bartender and order all the drinks from the menu. I want one drink from everything you have. And what the bartender does is he accepts the offer. He quickly passes us almost finished drink, latte macchiato in this case, which he happens to have prepared for a customer that just left. and then starts preparing all the other drinks. So we can conclude the drink that we were handed so quickly must be the one that Bob has ordered before us, because it's already half made by the barkeeper. Okay, if you know Spectre, you'll see the analogy. What are the main things that we want to transport with this image? And this is where we link back from the story into the real world. Modern CPUs use their capabilities to do things in advance, speculatively, in order to increase speed. So after Bob has prepared or has put his order, the barkeeper starts preparing the drink. And then it may happen that while these things are already in preparation, there are security checks. Things prepared in advance are made obsolete by security restrictions. In this case, Bob spots us, says, I don't want this information to leak out, and leaves the bar. And still, the barkeeper has started processing the order. And this is, again, what happens in the microprocessor. The microprocessor has already executed some pieces of code, but due to a security check, something done in the code, it decides that this order is no longer, or these instructions must no longer be carried out, so it forgets about them, or it doesn't, it discontinues the processing. And then we use a side channel attack. I think there was a talk about this earlier, where we cycle through potential data and check the speed of response. And this is what we do in the bar. The barkeeper serves us this already prepared things. In the computer, it is a caching mechanism which helps us to track this speed difference. And this leads to our gaining information that we were not supposed to. Not by directly accessing memory, that's what is prohibited by the processor, but by deducing from the speed of processing what went wrong. We then tried to apply the same example also to Spectre, and it works quite similar. There's not much change that must be applied to our story. The basic setting is the same. Bob doesn't want us to know about his favorite drink, but this time he is also a regular customer of the bar, and once he enters the pub, the barkeeper also already sees him coming and starts preparing the drink. Much before Bob has actually placed his order, the barkeeper says, okay, this is Bob, he's here every Tuesday, he orders his latte macchiato every Tuesday, though I can already start preparing the milk or whatever. I know he will order that same drink. And then the same example, Bob spots us behind him and intentionally orders something else. In this case, he says, I don't want those people to know I'm an Italian coffee lover, so I order a beer. But we still can do the same attack and cycle through all the possible drinks to see which drink is half prepared by the timing of the response. Again, matching to real world. Spectre is similar to Meltdown, but exploits the computer's prediction about the program flow, especially if that prediction turns out to be false. So the computer does, from training predictions, training is here the regular customer, predictions on what instruction to carry out next. And even if this turns out to be false in a specific case, we can use this to gain data or make the processor do things that are not intended to. Okay, this was just an experiment of thought. Can we use this bar example to explain the problems of these computer vulnerabilities? We carried it a bit further and asked ourselves, can we this also do for the remedies, for the things that have been developed to stop or to limit the problem? This actually works as well. Two small examples. We have one measure in the kernel code called kernel page table isolation. We can map this to the idea that we have two groups of customers: privileged customers, non-privileged customers, user space and kernel space. And we have a rule for the barkeeper that customers must be served from their own set of stock of drinks. So if they have semi-finished drinks for one group of customer, the barkeeper may not use it for the other group. Or another measure that was introduced were these process context identifiers, PCID, where we say during preparation each drink gets a label with the customer group, and semi-finished drinks may only be used for the customers of the same group. These analogies also help us see the problems. The problems of these remedies are that they cost performance, and we can directly see if semi-finished drinks may only used for specific customer groups. That means we have to prepare a drink all over again, even if I have a semi-finished drink at hand. So the barkeeper has to do a bit more work, and that is the explanation for the performance loss of these remedies. Yeah. Now, we have now chosen one image to understand what happens technically, but this image has also one interesting property, that it is a change of perspective, or that I can use it to change the perspective. I can set the focus of the audience to specific aspects of the problem, or I can spotlight specific things that are vital for the risk decisions. I can use this to show similarities to other structures that the person I'm communicating to is more familiar with. So if I talk about a cloud computing and virtual processes, maybe these people are not very comfortable with this, but if I use an image, they may have it easier to make a decision. So what we can do now with our image is change the perspective, use another image. For example, if we want to tell people what is the consequence of this problem. For example, if we talk about a cloud computing thing, we can use the image of a big apartment building where all the customers, all our virtual machines are apartments, and we have one janitor or facility service that has a key for all the apartments, which represents our cloud service provider or the operating system or the kernel, depending on what I'm looking at here. So we can, for a different question, we can choose a different metaphor to make things easily understandable. The claim is that only the tenants can enter their own apartments. The janitor has a key to be used only in emergencies, and now we can try to construct stories that tell how our vulnerabilities make these security restrictions overcome. So we haven't put this off in detail, but this is another example how we can use metaphors to make these things visible. But there are some limitations and some caveats which we should keep in mind if we use analogies, especially when talking about technology, and these must be kept in mind. We never should forget that it is, after all, an analogy that may work well for some aspects, but that is something different after all. So we may come to the point where there are aspects of the actual technical thing that we cannot cover with the image or the metaphor. In our example, for example, it is very difficult to find to explain Spectre 2 in a bar situation. We would have to bring up a story where we make the barman prepare something that isn't actually on the menu. That is a bit difficult. Sometimes, if you look at the metaphor, we may draw conclusions that actually don't mirror the actual situation. So we run the risk of getting lost on the metaphor. We like getting lost in translation. We are looking at a different situation, and maybe we discover this image and talk about I don't know the characteristics of different drinks, and lose the thought that this actually is only an image we're looking at. So we must be careful that we do not draw conclusions from the image that do not actually cover the technical problem at its base. On the other hand, simplification may also hide detail. People may draw wrong conclusions from a simplified abstraction. So if they say, now I've understood this, they may work on their simplified image of the problem and say, we have an easy solution, which actually doesn't cover the actual problem. And finally, there's a risk of sticking to the metaphor. The metaphor helps us transporting different thoughts, but we must abandon it once we've achieved this. If we keep thinking and talking in the metaphor, we will drift away from the actual problem and talk about the wrong things. Okay, let me wrap things up. What is it I wanted to tell you with this brief talk? If you need to convey a technical, complex problem to non-technical people, spend some thoughts in advance on how to do it. Try to find some images and metaphors which have a good analogy to the problem and which help you to explain things, but choose something that your audience is familiar with. Don't choose something from your own technical thinking, but spend some thought what is a real-world example that they can easily understand. Consider including some variants up front and make sure you know in advance how far the analogy will carry you and where its limitations are, so that if there is a discussion about your image, you can stop it at the right point and say, okay, now we are leaving the image because it will bring us to false conclusions. And once you have transported the principle that you want to communicate, stop the metaphor and go back to its mapping to the real problem at its base. Okay, our experience and our opinion is that using analogies and metaphors in this way will help you make people understand and remember. Something explained with an image like this will also more easily stay or be remembered by people. That was the barkeeper problem or the apartment block problem. So they can actually be of big help in this communication situation if they are properly used. So we must make sure we understand what we are doing and what we're saying and where its limits are. But then we think this is a good way of using images in talks about deep technical problems. Okay, any questions about this, or opinions, or things you want to share from your experience of this situation? Do we have a microphone? Yeah.
So in your experience, when you try to explain this any complicated issue to management, and they get stuck on the idea, did you ever experience that they get stuck on the idea, the image that you try to explain?
Yeah.
And how would you remedy that? How would you make him abandon that image in order to explain the issue better to him?
Yes, it's actually one of the main problems. I've experienced this situation multiple times, and this is actually where you have to stop talking in the image. You shouldn't try to extend the image or adjust the image to fit the situation, but you must say, okay, now this does no longer fit. Let us go back to another image, possibly, if you want to convey another thing, or to the actual thing.
Yeah.
Yes, I think it's one of the important things to stop using the image at the right point of time.
Exactly that. Sometimes non-technical people are stubborn and get stuck.
Yeah.
And how do you unstuck them? You stop talking about the idea, but they're still thinking about it. So,
Yeah.
do you have any methods on that?
You must. I think you should directly address to them that this is where the image doesn't carry you any further.
Okay.
Yeah, but after all, it remains a communication problem.
Yeah.
Yeah.
Thanks.
Thanks. Okay then. Thank you very much.